Alright, so today we're going to take everything that we've learned in the previous Unit 2 videos and put them into play as for solving right triangles. Okay, so there's a couple ways that we can solve right triangles. When I say solving a right triangle first, what I'm saying is I need to know the measure of all three sides and all three angles. Okay, so there's several ways that we can work problems like this, but if I say solve the right triangle, I mean give me every side length, give me every angle. Nothing needs to be left. Okay, now there are two different types of problems I can give you. I can either give you two side lengths. Okay, now we already know it's a right triangle, so I can give you two side lengths, or I can give you one side length and one of the acute angle measures. Okay, so automatically you're given a right angle, but then you need an additional either two sides or one side and one acute angle measure. So, but before we get too far, we need to talk about the inverse of sine. In order to find a missing angle, we're going to take and use the sine inverse. Okay, what that means is if I said to you that sine of A is 5/12, okay, what is angle A? Currently there is a sine on angle A, so you would do the inverse of that to both sides, and you would get sine inverse of 5/12. Okay, which would mean that the angle would be approximately 24.6 degrees. Now you're probably wondering, how'd you do that? Well, I want you to pull out your calculator. If you don't already have your calculator out, pause the video and grab it. Alright, so you can see here that I have my calculator. Let's make it a little bit smaller so we can also see what we're doing at the same time. Oops. There we go. So, in the previous problem I said the sine of A was 5/12 and that the sine inverse is what I needed to solve the problem. So to find the sine inverse, you were going to type the second button, which is the green button on your calculator, and then sine. What that's going to bring up in your calculator is the sine inverse with the parentheses. Now most times what we have here will be a fraction. Occasionally it'll be a decimal. So if it's a fraction, you can still use the N over D button for your fraction, or you can simply type in the decimal. Okay, for cosine inverse, you're going to do second cosine, and for tangent inverse, you're doing second tangent. Okay, now these could also be known as arc sine, arc cosine, and arc tangent. Okay, we will use sine inverse in my class, but just in case it shows up on an assessment or in a, if you're taking pre-calculus senior year, you may see it as arc sine, arc cosine, and arc tangent. That's more common in the upper level math classes. Pretty much in college, all I used was the arc sine, arc cosine, arc tangent. We didn't call them sine inverse, okay? So just keep that in mind, keep that in the back of your mind in case, you get up to those math classes. Alright, so let's do a couple example problems. Given that this is sine of A equals 0.5, what I need to do here is solve for angle A. So to get A by itself, I do the sine inverse of both sides. So sine and sine inverse leave me with just angle A. And then I have the sine inverse of 0.5. So you need to make sure that you put this in your calculator and that you have parentheses around your 0.5. Okay, so type sine inverse of 0.5 and tell me what you get. You should have gotten 30 degrees. Alright, let's go ahead and try tangent. Okay, so we know we have to do the tangent inverse because that's the inverse of tangent to both sides. Okay, making sure we put our parentheses around the decimal. So type tangent inverse of 0.1051. Remember that's second tangent and then 0.1051. What you should get here is 6 degrees. I know that you probably got like 5.999 something, okay? That's okay, we can round to 6. That's the reason why we go out for decimal places. if we'd only gone out 1 decimal place, then the tan inverse of 0.1 is 5.7 degrees, and that's very different than the 6 degrees we see here. Alright, and last but not least, we have cosine. So the inverse of cosine is, well, cosine inverse. So cosine inverse and cosine leave me with just angle A. So I have the cosine inverse of 0.7071. Oops. Putting parentheses around my decimal. And I get 45 degrees. So as you can see, it was like 45.0005 or something like that. That's why we go out to 4 decimal places, so it's very clearly 45. How I actually pulled this decimal was I did the square root of 2 over 2. Okay? Alright, so why don't you try these examples? Go ahead and pause the video, and then we will confer and make sure our answers are correct. Alright, so these are the answers that you should have gotten. I would be very careful in reading the directions as nearest tenth of a degree, so I would expect to see the 11.0 on your paper. Alright, so what does this mean for us? What does this mean in regards to other triangles? Now remember that in the very beginning I told you that in order to solve a right triangle, you need to solve all the missing sides and all the missing angles. Okay? One of the ways I can provide a problem for you is given the right angle and 2 of the side measures. So rather than solving every piece of the triangle, we're going to take it one piece at a time, and then we can put it all together for our problems. Alright, so this is angle X. We're going to start the problem like we always do, labeling the hypotenuse, the adjacent, and the opposite. So I'm given the opposite and adjacent, but nothing to do with the hypotenuse. So what that means is I'm going to be using tangent, because tangent's the only one that deals with opposite and adjacent. So tangent of my unknown angle X is equal to the opposite, which is 5.7 miles over 59 miles. So 15.7 over 59, I need to get the tangent off of X, so I'm going to use the tan inverse that we just learned. So I'm going to put in my calculator this fraction just like it is. Okay? And for X, I get 14.9 degrees. Alright? If I wanted to, then all I had to do is subtract from 180 to find this missing angle here. Alright, so why don't you try this problem right here. I want you to find the measure of angle X to the nearest tenth of a degree. Pause the video and give it a shot. Alright, so the opposite of X was 7 and adjacent was 5. So I'm going to use tangent here. The tangent inverse of 7 over 5 gives me my angle measure of 54.5 degrees. Alright, so here I want to find the measure of angle A and the measure of angle B. Notice that I already have all 3 sides of the triangle and I have a right angle. So in order to solve the triangle, all I need now is sine of A and sine of B. Now, from the perspective of angle A, this is hypotenuse, adjacent, and opposite. I could use tangent, I could use sine, I could use cosine because I have all 3 pieces here. So what I'm actually going to do is I'm going to use sine, so that would be 24 over 25. Then you're going to do the sine inverse of your fraction 24 over 25 to find the measure of angle A. Go ahead and do that now. Let's go ahead and round to the whole number. So I would say 74 degrees. Alright, now I erase these markings and I need to label the sides in the perspective from angle B. So 25 is still my hypotenuse, but 7 is opposite and 24 is adjacent. So we're going to continue with sine because that's what the problem says, sine of B. And it's opposite over hypotenuse, or 7 over 25. So I need to find the sine inverse of 7 over 25. So let's type that in our calculator, sine inverse of 7 over 25. I got like 16.26, so we're going to continue rounding to the nearest whole number, and I get 16. You need to be able to double check your answers. The 90-degree angle in the problem plus the 74 plus the 16 I found adds up to 180 degrees. So this is my way of checking and saying, hey, I did this problem correctly. Alright, now in this problem we need to solve the triangle, rounding to the nearest tenth in this case. First things first, I notice I have two sides and a right angle. If I have two sides, I can use Pythagorean's theorem to find the missing side. So 8 squared plus 10 squared will give me my hypotenuse squared. Okay, so this is my hypotenuse here. So 64 plus 100 is 164. If I square root that, I get C is approximately 12.8. And the reason I'm leaving it as a decimal and not as the simplest radical form is because it says round to the nearest tenth. So the missing side here is 12.8. However, I'm not done. Remember that solving a triangle requires all the sides and all the angles. As of now, I have all the sides and only one right angle. So let's go ahead and find angle A. So let's label the sides as it relates to angle A. Now here's my suggestion. I would not use sine or cosine because I had to round my hypotenuse. So that could affect the measure of my angle A. So what I'm going to do is I'm going to do the tangent of A is equal to opposite over adjacent. No rounded numbers here. So the tan inverse of 10 over 8, and I type that in my calculator and I get 51.3 degrees. Now I could subtract 90 minus 51.3 degrees and get my angle B, but let's go ahead and do this the tangent way, just because maybe I made a mistake doing the tangent of A. Maybe I typed 7 instead of 8. Okay, this is a good way to check and see if you did it correctly. So from the perspective of angle B, 8 is opposite, 10 is adjacent. So be 8 over 10. So B is the tan inverse of 8 over 10. So if I type that in my calculator, I get that the measure of angle B is 38.7 degrees. So when I add 51.3, 38.7, and 90, I better get 180. And I do. And since I do, I know that I have correctly solved the angle measures. Alright, so these are our last problems. Remember that solving a triangle requires all the angles and all the sides. I keep repeating it because it's very important that you understand if I tell you to solve the triangle, I'm not going to say find x, find y, find z. Okay? Alright, so in this triangle I have a 90-degree angle, a 30-degree angle, and this must be a 60-degree angle. Now there's a couple ways I can do this. I can use my special right triangles or I can use my trigonometry. So you don't have to use special right triangles now that you know trig. So let's go ahead and solve for x. I have 60 degrees. This is my opposite, this is my adjacent, and this is my hypotenuse. So I'm looking for x, and I'm given the adjacent, so that would be tangent of 60 equals x over 4 square roots of 2. So x is up high, I multiply 4 square roots of 2 times tangent of 60. Make sure that the tangent is not under the radical. And I get x equals 9.80, rounding to the nearest hundredth. For z, or the hypotenuse, I'm going to use cosine of 60. My variable's down low, so I'll divide them, 4 square roots of 2 over the cosine of 60 is 11.31. So I have solved all the sides and all the angles for this triangle. It looks like we won't have time for this second triangle here. That's all we have for today, and I will talk to you guys later.